You started?
Yeah, I'm just waiting for a few people to join in. As soon as we have some viewers, I'll start.
There are no viewers. So
I'm sorry.
there are no viewers. Silence seems to be.
Hello. Okay, Mayank.
Hi, Professor. How are you?
Okay, sorry, like I got the link little early anyway. So it's good. Finally, I copy pasted from WhatsApp, so it worked.
Yes,
Yeah.
Professor.
Still not. Okay. Yeah.
So, Professor, we are already online. To all the viewers, first of all, thank you for joining us in today's webinar. A very warm welcome to all of you to today's webinar, and also the Machine Learning Artificial Intelligence program by IIIT Bangalore and UpGrad. In today's webinar, we are going to talk about the preparatory course that we have launched today itself. And this is a 6-week program which lays the foundation for the next 11 months to come. The agenda for this program, for this particular talk, is essentially centered around 4 topics. First is we are going to talk about we are going to introduce the preparatory content itself. What are the topics that are going to be covered, and and why is it important for you to go through them thoroughly. Second, we are going to talk about what kind of a learning experience can you expect from in these 6 weeks. Then we are going to touch upon some basic do's and don'ts, and what are the best practices that you can follow over the duration of 6 weeks, which will help you get the maximum from this preparatory course. And finally, we'll talk about the differences that this particular program has from the main program. We are joined by Professor Sadgoban, who is the director of IIIT Bangalore, and I have here with me Mr. Mayank Kumar, co-founder and MD at UpGrad. So, Professor, why don't we start with you and just hear from you what is your perspective on the preparatory course and the content that we are covering?
Okay. Good evening. Good to see Mayank and Ravi. Okay, good. So, welcome to all the participants who are logged into this Google Hangout. And we will just, in the next about 45 minutes or so, we will spend on the program, which is specifically a prerequisites program or the prep program for your a full-fledged program on ML and AI. The 3 components of this preparatory program are as follows: Math and Stat, Python, and SQL. You may wonder why we chose this, because it is important for you to get a feel for it. Python is the programming language. There is a tool which will actually use to assemble the data, because and much of the AI, you would actually need access to the data. A lot of machine learning would also need a lot of data. And we will use Python as a programming language to be able to get access to the data and what we call the massage the data, and finally squeeze the data to get some juice. That's the whole purpose of this whole stuff. And of course, Math and Stat form the core tools for the entire AI and ML, because these are the tools that have been developed over several decades. And I think all these years, the ability to handle a lot of data almost in real time was just not there. Tools are getting a new generation of life, and that is how the Math and Stat actually comes. And finally, you need an interrupt? Can I keep going, or you want some interrupt?
Please go ahead, Professor.
Okay, go on. And of course, the last one is SQL. SQL, as many of you who have done an introductory course in DBMS would know, one of the important aspects of today's AI and ML is speed. As and when on the billion day, when the Flipkart or Amazon people are buying, at the central headquarters, you have to know how much is selling, what item is selling, which part of the country it is selling, and maybe minute by minute, if not every quarter, every 15 minutes, okay? And you can't wait for the analysis to aggregate for one day and give you the data, because billion days are only 3 days, okay? So in order to get that speed, SQL is the secret sauce which gets at a phenomenal speed structured data. While the world talks about unstructured data, but structured data will continue to be the key, because you still need products, you need the product price, you need the product quantity. These are structured data, and you have to quickly do a summation and addition, subtraction, deletion, all that, right? So these are the 3 tools which will form part of this preparatory program. And I will take another 1 minute to also tell you, some of you might have this one. I'm anticipating this and telling you in advance. See, SQL can be taught very differently to very different audience. Okay, the SQL which we will talk about will be primarily in our ability to get structured data real fast. And because the very large data sources are already structured in relational form, so SQL essentially becomes the easy way to get the data. So we are not going to do all of SQL, but we are going to do SQL to getting real fast structured data. Similarly, math and stat, we all have spent our PhD on that. We have done maybe 5 courses in mathematics and 7 courses in statistics. Obviously, we are not going to do all of it. We are only going to talk about math and stat relevant to AI and ML. And of course, you might ask, why Python? Python you can use to develop website. Python you can do to visualize. Python, doctors are using, biologists are using Python to do gene sequencing. So Python can be used very differently, but we are actually going to again focus on Python for ML and AI. Okay, so that is how the courses are structured. And of course, you do have a little bit of the details about what are the things to be covered. So what I would do is I would kind of wait for some time for you to kind of pop up some questions. Either you can do it in the next couple of minutes, or maybe Mayank can start and then you can start thinking about it. I am okay both sides, but I'm actually going to stay with Mayank for at least another half an hour. So I leave it to you, whichever way you want to pose questions.
No, thank you, Professor. So I think we will keep on waiting for questions, Professor. The moment we see questions popping up, we will send it across to you. I think, first of all, I'd like to congratulate each one of you who have taken up this particular program. Couple of sort of back-end secrets that I would like to share with you. One is, this is a program that we are doing after one of our successful programs that we're running with IIIT Bangalore, which is a PG diploma in data science. And during that conversation, we heard a lot from the industry that, look, data science takes you to a certain level, but we do require machine learning engineers, AI experts, and there's a lack of that quality talent. Now, at that point in time, we are very clear that whenever we start this particular program, this has to be an extremely selective program. And when we started, in your cohort itself, for every 1 person who got the admission, 2 to 3 individuals did not get an admission, which went through a rigorous sort of selection criteria. So you guys should be congratulated for getting selected into the program. This program, as Professor Sadagopan said, is going to be extremely rigorous because this program takes us from where our first program, which is the program on data science, leaves us with. We go deeper into machine learning and AI concepts, where things starts getting complicated, and therefore there was a strict entry criteria. Despite those entry criteria, we realized that there has been we have found gaps in domains of Python, SQL, and math, and basics of maths and stats, which is what we wanted to focus on the first part of the prep program. Now, in the prep program, guys, for you to access that particular program, you will have the platform login details shared with you all already. So you should log on to the platform, go through the various modules that have been listed. You will see that in each of these sort of modules, the prep program is broken down to multiple courses. Each course will have certain number of modules in it. And under each module, you will have specific sessions and case studies. The way it's designed is such that when you're going through these modules and courses, you're not just sort of going through the theoretical concept, but you're also seeing practical application of those modules as and when you go along into the program. Given that this is a prep program, I would still urge you not to take this lightly. This is where you set the foundation of what you will end up doing in the main program. Many of you would be familiar with Python, SQL, or mathematics and stats, so you guys would find it that this is a repetition of what you're supposed to be doing, what you know already. But I would still urge you to go through this because it's been designed keeping in mind what the full PG diploma program will cover. And therefore, I would urge each one of you to devote at least 10 hours every week. Find times during the end of the during the end of the day, once you're done with your office hours, to go through the program module, and then over the weekend to find more time to sort of finish some of the key concepts later. But that much amount of time is a must that I would urge you to, and that's a serious sort of feedback from my side. I've seen it in earlier prep program modules as well. That people have, sometimes people fail to spend that much amount of time and they don't get the maximum benefit out of this. The third critical part of being successful in this program is going to be the peer network that you have. As I said earlier, the peer network that you have is a fairly tight-knit community, and they have been thoroughly, the profiles have been thoroughly vetted by us, and therefore the admissions call have been given to each one of you. So you guys are amongst one of the best lot that we have found from the application. And therefore you should leverage the network that you have formed yourself. The discussion forum will continue, and there's a discussion forum that you'll find on the platform. Is a platform where you can raise the right questions and your peer members can answer those academic questions as you go along. Please leverage that to the best possible extent as you can, because that's the place where you will find the best of the ideas talking to each other, and you will counter question yourself, you will ask them the right question. This is the place where we try to replicate what in our offline classroom setting we call the peer-to-peer discussion. And this will play a very, very important role as we go along in the program. So that's in terms of the learning experience during the prep program. I'll move on to talking about some amount of support while you go through the prep program. Each one of you will be allocated a student mentor. He or she will be shortly introduced to each one of you. They will provide you with any kind of support to do with non-academic, which are non-academic in nature. So for example, when is the case study due? When should I submit my assignment? My login details are not working, so on and so forth. And therein comes a student mentor who will be the right person for you to raise those questions and queries. The TA support, which is a teaching assistant support, will be limited as you go through during the prep program. This is largely, these are not graded aspect, and therefore the TA support is going to be very light when you go through the program. The moment the main program starts, the TA support increases significantly. And therefore at this stage, I would, given that this is a prep module, I would urge you to sort of leverage a lot of what your peer-to-peer network is, and focus on talking a lot amongst peers as well, because you will see a lot of benefits coming to talking to them, asking them the questions. The faculty member on an ongoing basis will keep on coming to the platform. The TAs will review the platform as we go along. But I would urge you to sort of network a lot with your peers to get answers to some of the questions that you may have. Now, I would just sort of quickly touch upon some do's and don'ts before we get on to the questions.
Sure.
Can I start with the questions right now?
We have a few questions.
So we'll come to the question very quickly, but I have just 2 points to cover. One is just do's and don'ts of the prep program. This prep program, it's not graded, but please do not take it lightly. I would urge you to, each one of you, to develop a very strong understanding of the basics of maths and stats, SQL and Python, because these will be the foundation of what you will end up doing. And it's best for you to get those clarity right now rather than later. I have seen in our PG Diploma Data Science program, wherein learners who have spent sufficient time on the prep program, they seem to do better in the main program. I would suggest AI machine learning these are new areas emerging in the industry, and for these elements to be successful, it is very crucial for you to practice a lot. So there is a lot of amount of practice material that you will find during the prep program, but I would urge you to sort of practice even beyond that. I would also encourage you to sort of read up outside the content provided on the platform. While during the prep content, it is very, very useful for you to look at other resources as well. If there are certain places where you feel that this mathematics concept was covered in detail, but you for your individual sake want to learn more, there's enough online material available for you to go through. But I would suggest if you focus on this prep module, you should be able to execute successfully as you go along in the full program. Now, coming very quickly, before I come to the questions, what's the difference between the prep program and the main program? This is where the differences start coming in. So as you move towards, so prep program, as you guys know, is it's not graded, and hence there is not weightage that comes into grades that you will end up getting. But it's important for you to set the foundation as you go along. The key difference that you will find between the prep program and what you are seeing, what you will see in the main course, is a industry assignments and case studies. There will be multiple industry assignments and case studies that you will go through as you go along the program. So that's going to be a significant difference when you go to the main program, because that's when we get into the concepts, some of the key learnings have been brought in from the industry that you'll be actively working on. You will also work on real life projects, which will not be the case when you are sort of doing prep program. The TA support will be far more intensive and extensive as you get along into the program. The teaching associates in the main program will be actively reviewing the discussion forum, will be actively sort of answering your doubts as you go along, which will be light when you come to the prep program piece. The student mentor will also be far more active, not just in terms of non-academic query, but also helping you plan your studies. How should you set your learning goals? How should you meet your learning goals? And will also help you with the small hacks that would allow you to execute successfully, as you each one of you are working professional. And therefore, it is important for us to sort of give you a broad idea as to what is the best way in which you can maximum benefit from this particular program. There will also be a lot of industry lectures while you get to the main program. The faculty webinars will also increase in the main program piece. And those are the pieces where you will find it to be significantly different than what the prep program is. Having said that, I would urge each one of you to take this prep program very, very seriously. All the we do have prep program for data science as well, but you will not find Professor Sadagopan coming there and talking actively that you have to do it very carefully. But this program is an intensive, rigorous program. It gets on to far more depth than what we are going in data science program. It is far more complicated and rigorous than what we are going in our earlier program, and therefore it is important for each one of you to spend a lot of time in going to the prep program really seriously. We are tracking each one of your progress as you go along, and if we see you are lagging behind, we will sort of reach out to you actively. But please do take it very, very seriously and go through this prep program in the next 6 weeks' time, so that you are really, really successful. You're ready to be in the right frame of mind as you start the main program later.
Just one point to add to what Mayank said. The components of the prep course will be released week on week. So today we are releasing Introduction to Python. Next week we'll be releasing Introduction to SQL. Then a week hence you will get access to mathematics for data science. Then subsequently you'll get access to data manipulation and data visualization in Python. Now, before we get into questions, Professor, do you have anything to add?
Yeah, I just thought I will add 2 quick points. Some of you might ask this question, why this prep program? Part of it Mayank also answered. And let me tell you, because in all the premier institutes, we have some sort of a prep program for all our premier programs, whether it is an MTech or an MBA. Okay, and this is how we summarize the prep program. Doing well in the prep program helps. Not taking prep program seriously hurts. Okay, so I want you to remember this very carefully, right? Doing this helps, not doing this hurts. Okay, so that is a message. The second thing which I thought that I would like you to kind of think about it is, this is actually a general what is called the practice jnana. Okay, so because we all kind of keep teaching for 30-40 years, and what is one of the distilled piece of information for you is, that 20% is what you learn in actual classroom. In this case, it's a video. The 20% you learn by doing the homeworks and the projects. And the remaining 20% you learn by the peer group. That is the reason why peer group is so important. Take it very seriously, okay? It is important to post questions. And sometimes when you try to explain to others, you get much more clarity. So keep doing that. And because most of you are working professionals, I would strongly urge you, take up some projects. You know, you all deal with so much of numbers and so much of stuff. Take any one of them. It could be from some data about telephone churn, or it could be something else, or you are kind of trying to find out if you're in a hospital situation, is there some particular pattern to a particular way in which patients arrive, a particular time, etc., etc. And then make it into a small project and solve it. That is a 20%.
Yeah.
The last part of 20% is what you learn in your life. So nothing we can do about it because you can't how to be learning. Okay. So remember this, it's only 20% what you learn. Equal 20% is you to learn by doing the projects, and another 20% from the peer group. Okay, so do take all of these things. It is important to have a holistic view of learning. It is just not listening to lectures. It's good, but I think you need much more.
Yeah.
Okay.
Yeah, I completely agree, and I just sort of echo what Professor Sadagopan said, which is picking up your own proof of concepts in your existing firm. Whatever that you're doing, if you're, if you're, let's say, I'm just giving a very mundane example. Even if you're in a, let's say, in a manual testing or bugs or identifying sort of testing zone, look at the bugs that you've identified. Can you build a predictive model around that? In our program, we have seen people who have spent time on building these POCs early. They tend to sort of find the career transition much faster. So I'll just raise some questions between Professor or Ravi. We should be able to answer that.
Sure.
So Ravi, there's a question which we are asked, which has been asked, which is, are we going to cover Tableau in the prep program?
No, so Tableau is not being covered in the prep program. This program, like we said before, is much more advanced. And this does assume people to have some background in programming and either some background in programming or some knowledge of data. And when it comes to Tableau, it is generally used in visualization. And we are already covering, and the industry itself is moving towards data visualization using Python from Tableau. So I think that is already being covered. So Tableau per se will not be covered.
Sure. I think, we don't, Tableau, we do have strong material that we have created, but I guess for this particular program, the focus is far more advanced version, and that's why Python visualization is what we are covering on that.
I will put it this way. You see, a Tableau is a tool that gives you an ability to do certain things which are kind of canned or pre-programmed much faster, far easier. Okay. But obviously, this course aims to develop you to much deeper. So obviously, when you do Python, you can do much more. So whatever a Tableau can do, you can do with Python.
Yeah.
But what you do with Python, you may not be able to do in Tableau. I think that is where is the distinction.
Fair point. Professor, this is slightly technical. Maybe you have you can answer this question. Will this particular program cover big data analysis as well, which is one of the best ways of running machine learning and AI algorithm when we have terabytes of data coming in? So maybe we don't need to answer whether this course will cover, but if you can guide the learners when they have terabytes of data coming, machine learning and AI algorithm, how does it work out in Python or Spark, etc.?
Okay. See, there are two aspects to the big data, because there are a set of people who are looking at humongously large data. For them, that is a big data. Okay. So what happens is, if you're really talking of genome sequencing scale data, or are you really talking of the entire author authentication data of a month? Okay. So those kind of data are much larger. What happens is you actually need a little more of specialized knowledge, etc. Obviously, we will not do it here. What I would say is, think of it, so you can build skyscrapers of 10 stories and 12 stories, right? Then you have Empire State Building, right? So Empire State Building would need little more of extra stuff because you can't do many of the stuff, etc. At the same time, the amount of data which you can handle today, just to give you one data point, some of the students in IIITB for one course and one project of one course to have, there are some data available. You can analyze 1 million email and to find out what is called the intent analysis. Is this person likely to commit suicide? Is this person likely to be a terrorist? Those kind of, okay, it's called, okay, intent analysis. Okay, so 1 million email until about 5 years, 10 years back would have been really large. Okay, but today it is not large. At the same time, are you talking of hundreds of terabytes of data? That kind of a big data?
Yeah. No, fair point. This is slightly more about the program, so maybe you can answer that, Ravi, which is, are there going to be any access to tools, labs for practical practice for machine learning and AI algorithm?
Sure, absolutely. So if you see a lot of machine learning and advanced artificial intelligence work is being done on, there are a lot of advanced libraries available. And especially when it comes to neural networks, deep learning, running such advanced algorithms, obviously they require a lot of processing power and much more space than what a normal computers can suffice. So you will, as you go through the program and when you will be working on some of these advanced projects, especially deep learning, deep learning neural networks and courses beyond that, you will be given access to AWS and libraries from Keras and TensorFlow. So yeah, that functionality is definitely available to you. Apart from that, some of the libraries such as NLTK, which is used heavily in natural language processing, will also be made available. Python generally is an open source tool and which can be used pretty much by everyone. So yeah, so on the tools front, that's about it.
Sure. Professor, there's a question from Vinaya. The question is that how should they think about the current research that is going on, because this field is ever evolving, and what we will learn during the program? And the specific question is, would we be learning the latest research work going on in AI and ML? And would research papers, NIPs, etc., would be discussed in the program? Given that it's a fast evolving space, you may perhaps want to throw some light on that question as well.
I think excellent question. Okay, my answer would be what we call yes and no. Okay, the reason is, okay, while for many of you, things like NLP, things like machine learning, things like AI would be completely hot and yesterday, it just came yesterday. It's actually not true. Okay, so many of these things have been around for a reasonably long time. But what happened was it fell in place so that things are possible. So we did not have enough computing power available. We did not have connectivity available in machine readable form. Okay, that's the reason why a lot more interest is there. So what you will find is, I would say about 70% of the course would be what has been evolved, what has even matured, possible to kind of practice. But because of the enormous amount of potential applications that have spawned in the last couple of years, maybe 5 to 10 years max, so a lot more people are working in this area. So a lot more research is happening. We are quite connected to all of them. And, with no arrogance, I would say, the Indian research community in this area is as contemporary as you will find in MIT or Stanford. It is not that, see, in many areas we were decades behind or many years behind. It is actually not true. We are quite connected. So a lot of them would have access, but how much of it you will be able to pick up is also, because, see, many of the time you might need a certain amount of research work already done in that area. If you have that background, you'll be able to pick up. I would say about 30% would be the contemporary research that is going on elsewhere. 70% is past research available in a significantly structured form. Answered your question.
Fair point.
Thank you.
Fair. Professor, just one question which you could perhaps just quickly point out, which is Sushant had asked this question: what is the difference between this program and the data science program? And maybe the better way of answering that question would be, why did you decide to do this program when you had a data science program already working going on?
Okay, once again, a very interesting question. And this is not something which we kind of did it just like that. We kind of thought through it quite a bit. See, to some extent, when an area is very hot and lots of activities are happening, the terminology means different thing to different people. At one level, you can say data science encompasses everything, right? It includes analytics, it includes AI, it includes machine learning, it includes big data. But what is happening is in the real world, particularly in corporate sector, to a large extent represents analytics, visualization, and big data. And normally ML and AI are considered outside of this. And we also find that there are a lot of jobs, there's a lot of talent, needs of talent in data science, but equally large, sometimes even larger talent is actually needed in AI and machine learning. Okay, so because of that, we feel that a focused program, which is more on AI and ML, would be kind of necessary. It is partly the emphasis is slightly different. Okay, but don't get too carried away by, if I have to, as I'm wearing a pure academic type hat, I would say data science includes everything else. In fact, I can even go one step further. Computer science includes everything else. But, computer science, right? But I think what happens is you have to be up to date, you have to be contemporary, so things kind of keep changing. Because finally, when you are actually going to have a client who actually wants you to solve a particular problem, the chances are they will come from the ML and AI. The generic term, you may not have the right resonance with the client, and that's the reason why we need to do. So I would say that what we have done in data science program so far is a much larger focus on analytics, and this program does much larger, a much deeper focus in machine learning and AI.
Got it. So there's a question by Amarjeet Sahu. Maybe Ravi, you can answer this. How can we reach the professors for doubt? Or I can pick this up just to sort of answer that point. So there are 3-4 places where Amarjeet, you can get in touch with faculty members. One is on the discussion forum. Whenever you raise a question, and if those questions are not immediately answered, it reaches the faculty member, and faculty member sometimes jumps in to answer those questions. Over the weekends or over the fortnight, once in a fortnight or once every week, we do have a lot of live sessions scheduled. So the faculty members come there to answer some of the key questions that may have not been very clearly answered during the program itself. So we try to do the flipped classroom where, or rather more a Socratic way of learning, where you go through whatever is there in the program module, and we leverage weekends for any kind of doubt clarification, doubt solving. So that's how you can potentially reach out to faculty members during the program. Professor, there's a question maybe you can throw some light on. Kunjal Patel had a question. How important, what role does machine learning and AI plays in computational neuroscience? It is going too technical for me, so I think I just sort of pass it on to you to answer this question.
Okay. See, computational neuroscience, you could possibly view it from 2 different points, right? See, obviously, neuroscience is an area where knowledge is still scratching the surface. Okay, just to give you some numbers, like some of the neuroscience labs, funding for just some of the labs runs into hundreds of millions to $1 billion. Okay, the number of neuroscience people available globally is just a few hundreds to thousands. So there is a lot of work to be done. Okay, so what happens is understanding neuroscience, etc., far more depth into the very science of it, the very medical part of it, the physiology part of it. Okay, so those things are one. The other part is you have lots and lots of patient data. So based on the patient data, there are lots of learning algorithms that have come out. And some of the learning algorithms would actually use AI and ML. Okay, so in that sense, whether it is a patterns or patterns of application of a particular drugs, what happens, and then association of certain diseases with certain locations, certain lifestyle, certain patterns, some food, etc. All of them ML will be used. Okay, and you actually find some of the doctors doing an ML course so that they can get it. Okay, the chances are, because they are domain expert, they have 10-20 years of expertise in neural science. If they can pick up, will run much faster than any of us.
Yeah.
But many of the doctors find it difficult to kind of spend that time to learn. They would rather hire an ML expert. The tools, they will tell you the context, they will give you the what is called domain knowledge, and together as a team they would do it. And that is likely to be, and in those areas, obviously, neuroscience is a big target area for AI and ML. And you can actually go on Google, you will find hundreds and hundreds of papers.
And Professor, that's why sort of that leads me to the next question, which is you said that domain knowledge is very important. We also spoke about computer science knowledge is very important as well, because you're building sort of a strong computational way of solving that particular problem. The third piece which which this program focuses a fair bit on, is the mathematical understanding of that concept as well. The mathematical derivations and the mathematical concept takes a fair amount of time, and you can write PhD papers if you want to get into support vector machine or neural networks or random forests, etc. Abhishek had a question when she's asking, do we get hands-on knowledge of mathematics behind all algorithm? And I know that there are certain places where faculty will go deep, and certain places they say this is what is required. But would any advice for people who are getting into AI machine learning domain, how much they should get into the mathematics side when domain and computational side is equally important?
Okay, again, excellent question. This kind of dilemma exists in many areas which are kind of interdisciplinary. I'll give an analogy so that it becomes easier for you. If you really look at people who analyze, say, Wall Street analysts, okay, so the underlying phenomenon of stock trading would actually need a far amount of economic analysis, right? Because economic analysis is the one of the Nobel Prize winning economists wrote a book called Portfolio Analysis, right? That's how the whole thing came. So the question is that, would knowing every bit of contemporary economics and being able to master all the Nobel Prize winning economics work, or being able to be a very first-rate investment banker or a first-rate Wall Street analyst? The answer is kind of yes or no. So obviously, without going through a good course in macroeconomics, you will never be able to get onto this job. At the same time, just because you understand economics such a depth, you still may not be able to do it. Okay, it is partly be able to contextualize that knowledge. So people who actually create machine learning algorithms may not necessarily be very good at solving a particular problem, whether it is a traffic or logistics or medicine or health. And you see, you look at it, like many of the people who actually build a skyscraper or a very specialized civil structure like the Sea-Link in Bombay, okay, they may not be the people who understand every bit of geotechnical engineering, but they understand enough tools. They're able to contextualize and then be able to turn that knowledge into something called a meaningful project or a product.
Yep.
I think that is the same kind of stuff you have to really look at it.
Yep.
It is the knowledge, but contextualized. The long answer to a short. Sorry about it.
Absolutely fair point. I think Abhishek, I'll just add one thing to 2 points on top of what Professor mentioned. We need to be very careful about 80-20 and where do we want to focus a lot of energies into, and therefore we need to go as to how much depth we want to go into that particular mathematical concept behind a particular algorithm. And because, as Professor mentioned, that you can potentially end up doing a PhD in that particular topic if you go more into the mathematical derivation. Having said that, my second point is that for each of these particular concept that we will be covering, the faculty member will provide you with the mathematical intuition behind that particular algorithm. So if we are learning about, I don't know, let's say an SVM, the faculty member tells you as to how that line particularly divides classifies the two sets of audience into two separate halves, and you will get the mathematical intuition. But perhaps we will not get into the details of gradient descent and how it's being calculated, so on and so forth, which the assumption is that you understand local maxima, local minima, and you'll be able to derive it. But the program does not get too much into the mathematical derivation of that. It focuses on the intuition such that you can apply to a business context. Professor, Amarjeet has a question, and I can answer it on your behalf. He has asked this question whether regarding research papers, can we get the research paper which are accessible to IIIT Bangalore students? I think Professor Tricha had mentioned this earlier. I'm just sort of leveraging what she said, that you will have access to library. And if you have any sort of pointer there, you can get access to the research paper that the students on campus also have access to.
Okay, see, what happens is that all the libraries follow a standard kind of a practice. Whatever is available to a member of the library would be available to you as a student. Okay? Perfect. So, because, certain things are restricted, even for us, certain things we can access only when we are physically on the IIITB network. You can't access it from home. Yep. Okay? Because that is how the licensing is. Okay? It's all subject to the standard licensing policy.
Yes. Yeah, for some games, you have to go through some pains. Which brings me to my next question from Amarpal Professor. He's asking whether could you perhaps guide him on certain areas in electronic design automation where machine learning can be applied. So I know it's a very niche case that he's looking at, but basis your expertise and experience, are there specific areas that you can guide him on?
Okay, see, it's very simple, right? Electronic design automation is all about getting phenomenal amount of efficiency at the design level and manufacturing level of electronic circuit, right? So you have companies like Mentor Graphics, they produce amazing kind of tools. So what happens is that many of the optimization that has been done, okay, now what we have is, we have years and years of fab expertise, right? Have been produced, and lots of data is kind of available. So you see, one of the important things in a chip design is what is going to be the yield. That means, what is the number that is going to be defective. So historically, using physics principles, people have been able to predict. But because people have not really used the data-based one, simply because the data is much larger. But today, thanks to the big data and machine learning, you are able to do. Second thing is that as an assembly line is doing, you have enormous amount of data, so you will actually be able to predict before a potential failure can happen. So obviously, in the manufacturing, one of the things I can tell you is that many of these things have phenomenal amount of cost implications, savings implication. They may save millions and millions of dollars. So obviously, these are kind of secret sauce available outside individual companies. You cannot find papers which talk about it, simply because this is something which is a commercial advantage to the company. But lots of machine learning happens in EDA.
Yeah, I completely agree. I think very interesting learning from that, what Professor mentioned is as long as you have a very strong contextual and domain understanding, you would know what data to sort of leverage to predict certain behavior, to classify certain things, and to sort of make a particular suggestion. And that's where a lot of what you would do in this program is keep the domain knowledge at the back of it and try to see the various use cases and application of various algorithms. If you get that intuition of it at the end of the day, you can go and look at rainfall data to election data to transaction data to sort of Flipkart and Amazon example that Professor gave at the start of the program, and you will come up with various use cases to this. Professor, with this, we have come to an end. I mean, there are no further questions that I have. I would leave you with any...
One thing to check with you, because I have to kind of log off in another 5 minutes.
Sure.
I have one. Okay.
Yeah.
Yeah. So go ahead. I'm here for another 5
No,
minutes.
sir, my question is just back to you because we are done with all the questions. Any last piece of feedback, advice for the learner community?
Okay. So all that I would say is that, those of you who are entering the AI ML area at this time, you are kind of lucky because you will have the early mover advantage. I would say 5 years from now, okay, I use a term called the machine learning will be tomorrow's spreadsheet because it will be so widely used in so many places. And how many things people do with Excel? Nobody knows, right? That is the level to which people have done, right? So similarly, ML will have the same thing and AI will have the same thing. So because it is going to be so widespread and so widely used, people like you who are entering this early will have the early mover advantage. And then I would say, just count your blessings, put your best efforts, and because there is so much of talent shortage today, even if you do well, there will be jobs, you'll get a pat on the back, you'll get your increase, etc. But that should not make you ordinary. Try to be extraordinary. Just because you can get away, you should not stop being good. You should be exceptionally good. Attempt to be exceptionally good. And I can also tell you that this talent is needed all over the planet, all over the industries, right? There's not a single industry which will not benefit from AI and ML. So you can, if you're an analyst, you can move from one to other, or you may align yourself to one industry. Within this, I'm going to be the best. You may actually become the ML for the hospital. And I would say that, look, the best hospitals would need you. Or you say that, look, I would be the general analyst, then Accentures of the world would need you. So this is a positioning which you have to take. Make the best use of it. And then I would say, reach for the moon. Or when my good friend Dr. Kalam used to correct me, don't limit people's thinking to moon. Today they should reach for the Mars. That's what.
No, thank you, Professor. Thank you
Okay.
very much. Thanks a lot for your time.
Thank you. Thank you. That's Ravi. Finally, it worked. Sorry, we lost about 5-6 minutes.
No problem. Thank you very much, guys, for your time for doing this. I'd like to sort of wish you the best for this particular program. There's a lot that you have to go through. Take the prep content very, very seriously. There's a fair amount of activities all planned out as you go along. It's a great time, as Professor mentioned, to enter into the AI/ML domain. But all of that will only bear fruit if you are putting in the right effort and sincerity and dedication. And that's what we're expecting from you from this particular program. So thank you very much, guys, and have a good week ahead with you. Thank you.
Bye. Good night.
Bye-bye. Good night, Professor.
Good night.